We feel very passionate about giving undergraduate students a very real opportunity to participate in a variety of research projects throughout their 3 years here. In addition to lectures and teaching sessions, we have a fantastic opportunity for undergraduate students to participate in a variety of research projects, leading their own research, participating in cutting-edge international quality research that we do here in Southampton. We have research assistant schemes that allow students to become research partners, if you like, supporting existing programs of cutting-edge research. I think it's fundamental for them to be able to translate what they hear about in lectures and read in their textbooks into practice, and to gain first-hand experience of what it's like to complete research that's at the forefront of the academic discipline they're studying. So in my own lab, we conduct a series of projects that are trying to better understand why people experience anxiety. And anxiety disorders are very common, and there are a variety of subtypes of anxiety, but all are associated with irrational fear, nervous apprehension, worry. And a variety of projects that we're conducting here in Southampton are trying to establish links between brain function and some of these problems in thinking, worrying and behaviour that characterise anxiety. So in our own research, funded by the Medical Research Council, we are developing this model of temporarily increasing anxiety in healthy individuals, and one technique that we're using is the inhalation of carbon dioxide. We encourage healthy individuals to come into the lab. They're screened to ensure that they have good physical and mental health. They complete a variety of self-report questionnaire measures of mood and anxiety. We measure their heart rate and their blood pressure. Participants will then inhale normal air that is enriched with 7.5% carbon dioxide for 20 minutes. And in doing so, they will likely experience increased feelings of anxiety, perhaps more worries. They will experience an increase in heart rate and autonomic arousal, so blood pressure. And that will rise quite early in the inhalation period, and they will remain quite anxious for the next 20 minutes whilst they inhale the gas. And during that time, we're able to look at how their cognitive system is processing emotional information that we present to them in a variety of experimental computerized tasks. We measure their eye tracking to see how their attention is performing. We can take EEG cortical recordings to look at how their brain is processing different types of information whilst they're in this experimentally induced state of anxiety. Our research group in Southampton is the first to use this experimental model of anxiety to evaluate psychological treatments and interventions for anxiety. This type of research allows good collaboration with industry partners, including the pharmaceutical industry, to develop and perhaps fast-track the evaluation of potential drug treatments for anxiety before we develop them and roll them out into full clinical trials in patient groups. Likewise, we can liaise with our partners in local mental health clinical psychology services to evaluate new psychological treatments that might help people reduce levels of anxiety they experience on a day-to-day basis. And experimental models like carbon dioxide inhalation do provide us with a quick and effective, safe and reliable technique with which to evaluate a variety of interventions. We're very excited by it, and the undergraduate students that have been involved in these projects this year have been particularly keen to be part of a project that has obvious application. Good science, but also relevance to improving the outcomes for people with anxiety in the future.